Okay, we have a set here calling S. Capital letters are usually used to name sets, and I've called it S because I'm going to consider it my sample space. It's an example of a sample space anyway, with a set of possible outcomes. And then I'm going to define another set, A, which you can see is a subset of S, and also B, a subset of S. Now, these are three sets. Two of them are contained within the other. And I also noticed that A and B have some elements in common, 19 and 61. I can draw a picture of these sets together using what's called a Venn diagram. I'm going to let the rectangle be the sample space, and then I have two sets, set A, and that's a subset, so I'm going to let a circle represent the set A. All of the elements in set A I can think of as inside that circle, and everything not in A but still in S is outside the circle. So my rectangle is S, all of the elements, and A is just a subset of it. B is another subset of S, but I'm going to draw it in such a way that it overlaps A because they do have some elements in common. So I'm going to indicate that by drawing another circle for B, but overlapping or intersecting. Now I'm going to put the elements in the different places in this diagram. Notice that A and B do have elements in common. That would be the 19 and the 61. Values that are in A but not in B would be the values 12 and 109. So everything in the red circle are the values in A. Everything in the blue circle are the values in B. So other than 19 and 61, I would have 7, 52, and 78. So those are the values that are in B but not in A. 12 and 109 are values in A but not in B. And the intersection, or the elements that they have in common, are the 19 and 61. So the Venn diagram helps me organize the data in the data set. So I can see clearly what's in B, I can see clearly what's in A, and I can see clearly what's in both. I can also see what's in one and not the other. For the remaining of the elements that are not in A and B, but are still within the sample space, what values are they? So we'll put them outside. For example, 3. 3 is in neither A or B, but it's still within the sample space. The next value is, let's see, 7, 12, 19, 52, 61, 78. Yeah, so the next value would be 109. That's still in A. So the next value would be 142. I'll just put it anywhere outside of A and B, but still within the sample space S. And 153 is outside of A and B, but it's still in the sample space, and actually 197. So there are 4 values outside of A and B, but within the sample space. Now, to use some new notation to indicate the different parts of this Venn diagram, I would say A intersect B. I would write A intersect B, meaning all of the elements that are in A and B. So that would be just a set including 19 and 61. So this would be A intersect B. Okay. Another way of combining sets is the union. The union is the set of values, in this case A union B, is a set of values in A or B or both. the values in A or B or both. So, what's that set of values? That would be 7. 7 is in B, so it's in A or B or both. 12 is in A. It's not in B, but it's in A or B or both. All the values that are in A or B or both. 19, that's in A. It's also in B, but it's a part of the union. And I only mention it one time. So it's just the set of values that appear in one or the other or both. So 19 satisfies that. The next one would be 52. That's only in B, but again, it's still in the union. 61, 78, and 109. Notice that in the Venn diagram, it's the set of all the values contained in A union B. It's sort of bringing all the values in those sets into one set. And it's just naming the values that are in that combination. We can also talk about what's called A complement. A complement is the set of all values that are in the sample space but not in A. And those values would be 3. 3 is outside of A, but it's still in the sample space. 7, 52, 78, 142, 153, and 197. So all of the values that are outside of A but still within the sample space is called A complement. B complement would be the set of values 3, 12, 109, 142, 153, and 197. So these are all the values outside of B, but still within the sample space. Okay, let's take A union B and find the complement of it. In other words, what are all of the values in the sample space but outside of A union B? Looking at the Venn diagram is a helpful way of seeing what these values are. I can see 3, 142, 153, and 197. So all of the values outside of the union of A and B, but still within the sample space. What are the values? 3, 142, 153, and 197. Okay, one more here. I've got A complement intersect B. So we're looking at two sets that we're intersecting. The first set is A complement. It's all the elements outside of A. And the second set is B. And what do these two sets have in common? What are elements that are in both these sets? A complement and B. So looking at the Venn diagram, I can see that that's going to be 7, 52, and 78. Again, the Venn diagram is a very helpful way of organizing the values in these sets so that we can see what is in A complement intersect B. The values in B, but not in A. Venn diagrams helped us to find these various combinations of subsets. In probability, events are subsets, like this A and B. Venn diagrams will come in very handy when we want to find the probability of combinations of events. And that's what the rest of this chapter is about.